Hello, everybody, and welcome to TriStar's presentation, Speed Up and Modernize Your Product Design Process with Cloud Native CAD Development using Onshape. My name is Shawn Schreckengost. I'm a TriStar Business Development Manager specializing in PTC CAD products. So today we're going to talk about, and just a brief introduction to Onshape, which is a new acquisition from TriStar or from PTC last year before. And just a quick introduction and show you how the tool works. But before we do that, we want to talk a little bit about how digital has transformed to the cloud using CAD programs in specific. But you think about back in the 60s when mainframe computing came on the scene. That was kind of a lot of hardware and things to manage as far as using computers back then. And I've been doing CAD for quite some time now. I've been spinning CAD products since the early 80s, and we'll talk a little bit more about that. But in the 80s, these tools started moving to more of a client server type infrastructure where we had a client workstation and then a server that served the data or the CAD tools or what have you. And then into today's world, a lot of tools are moving to cloud-based applications. If you think about Google Apps and Salesforce and some of these other type applications, they're all cloud-based today. So we'll talk a little bit more about cloud-based applications throughout this discussion today. But to understand a little bit of where we've been and where we are today, we'll talk a little bit about how product development is still kind of lagging behind a little bit. So with that, a brief history of product development, especially in regards to engineering and CAD tools. I mean, if you think way back in the day, old school design platform was really a drafting board, and we did drawings on vellum and using a big drafting table and drafting machine, and this is where I started. Actually, I've been doing this for quite some time. So I actually worked in an environment exactly like this, where I had a drafting table, and we had a set of drawers in the back of the room that you can see here in this image. This was our data management, if you will, because all of our drawings were kept in these file cabinets. And so when we came into work each day, we went to the file cabinet and we opened up our drawer, and in the drawer was an assignment, and we had maybe a new drawing or making changes to an existing drawing. But we would take that out of the drawer and go back to our own drafting table and tape it down to the top and start to work. And then at the end of the day, we'd put it back in the drawer. And so that was our data management system. Not really that efficient, and certainly if something were to happen to these drawings, we could lose a lot of intellectual property. So if we think about early mainframe systems, and this is when I started doing CAD work back in the early 80s, I was working out in China Lake, California, which is one of the largest Navy bases in the world. And this is where they develop and manufacture to some extent and test some of the airborne naval weapons systems, such as your Sidewinder missiles that you see here on the ends of the wings of this jet aircraft, and then a Sparrow missile, which is a air-to-air guided missile, where the Sidewinders are a heat-seeking missile. But this is where I actually got my start in engineering. And what we would do after we moved to doing CAD work on the computer is we had a mainframe system where we had a terminal that we did our CAD work on this big, tube-based monitor and a digitized tablet. We didn't have a mouse. We had a pen with a wire coming out of the back of it and a couple buttons on it. But everything we needed to do our work was right here on this very large desk, and we had a printer and a keyboard and all that kind of stuff. That, not too far away from what we do today, but still we had the same kind of needs to interface with the computer. Well, what we would do each day is, we'd come in and we'd have a work assignment just like we did on the drafting board, and that work assignment was loaded onto a disk pack, and this each of these workstations was attached through a series of cables in the floor into another room into one of these disk drives. And believe it or not, these are very large disk drives. One of these disk packs, you can see the handle on the top of this disk pack. I mean, that gives you an idea of how big these things were. They were probably about 16 inches in diameter and a stack of 12 disks. And they didn't really hold very much, but each day that disk pack was loaded into the machine, and it had to be done by somebody else on contract, and that's how we accessed our CAD data. Well, if we had to, get new data onto that disk pack was loaded up from a DAT tape machine, right? So they would load the tape onto the machine, and then that tape would transfer the data to the disk pack so that we could access it from our workstation. And these data tapes were pretty big. You could put your arm through one of the holes on these tapes, and they would hold a lot of data. And at the end of the day, all of this stuff had to be secured because we were working on DoD programs, and so they would literally store the tapes in a vault. And that's exactly what our vault looked like back in the early 80s. So you can imagine the amount of effort it took to manage these mainframe systems and to do what we do today on a laptop. And in some cases, we can do it on a tablet, right? And so very antiquated system, but that's what we had back then. And in that day, in the early 80s, that was state of the art, and we thought we were pretty cool to be working on that kind of stuff, especially being out there in the middle of the desert and watching all these jets fly over all day. So if we look at the early transformation into the tools that we use today, back in the mid 80s, Autodesk was available on a DOS platform. It was basically just two-dimensional, and we create drawings, right? And that system was about $5,000. And today's, that'd be a lot more today as far as its value per cost. And then in the late 80s, PTC came out with Pro Engineer, and that was on a 3D Unix-based workstation, and tens of thousands of dollars just for one seat of software, especially if you had everything that Pro Engineer would do, with the simulation and everything else that came with it. You could spend quite a bit of money on just one seat of software. And of course, that had to be supported by, quite the infrastructure of a Unix workstation and a file server and all that kind of stuff. And then in the mid 90s, SolidWorks came out, and that was on a Windows-based PC and 32-bit, and a little bit cheaper than Pro Engineer. But by then, PTC had already caught up with the Windows-based PCs, and you could get Pro Engineer on those machines as well. But SolidWorks was pretty innovative in its platform and how it was available. So what do they all have in common? Of course, was they used files, right? We would store the files on the local computer. We maybe put them on a disk drive to share them, and load them on another computer and do work on them. But we really didn't have any way to necessarily transfer data to our customers or other vendors and suppliers if we needed to, because they had to be attached to our system. So the only way to transfer that was through email or put it on a floppy drive. So that's kind of what they had in common. But if we look at how that system worked, it was really no different than being in that drafting room where we had copies of the drawings on our desk, and we stored them in the file cabinet at the end of the day. certainly, although it was digital, it still, resembles what was being done back in the, 60s and 70s, and even into the early 80s. We were still doing drawings on the board, and some people still do drafting on the board to this day. It's very rare, but it's still being done, especially if you look at some of the architectural drawings that are being created. That's kind of an art form, if you will, to create architectural drawings and renderings by hand. So what's wrong with files? Well, they cause a lot of work, and they're not necessarily the most up to date. If we look at the development process today, we have typically a CAD user that creates CAD drawings or CAD data on a CAD system, and so they're basically creating files of their work, right? And they're saving that on their system, right? And then they may share that with another CAD user, or that other CAD user is making their own data. And then we also need to share that with our suppliers, our customers, and other departments. And so what we would do is we would, transfer that data either in an email or put it on a USB, thumbnail drive, and basically sharing those CAD files with other users and so on. And so, although, it worked, it wasn't necessarily, the most efficient way to share data. And of course, we're sharing this back and forth through the same system. Somebody emails me some files, I do some work on them, I email them back, and they load that onto their machine, and then they do some work on it, and it goes back and forth. And there's really no guarantee that, we're working on the latest and greatest version of those files. So, we took that to a step further, and we started putting things on a file server, right? So everything we access is coming from the server, but even still, that data is versions or copies loaded on the file server, right? And then even still with PDM system, it's more managed, but it's basically versions of our CAD files stored on a PDM system. And then when we want to work on those versions, we kind of copy those versions into our workspace, if you will, so that when we're working on our data, we're storing it locally on our workspace, and then we load that back up to the PDM system for other people to see. But there's no guarantee still that what I'm looking at is the latest and greatest, because somebody else might be making some changes to it, and I can't see that until they load that up to the server, and then I get a indication that there's some changes being made. But nonetheless, we're still working with versions or copies of that data locally. So with that, excuse me. So with that, then we have to share that data with our suppliers and our customers and other departments. And with that, we typically send it out on an email or on a thumbnail drive, because those suppliers or customers, those other users or consumers of the data, don't necessarily have access to our PDM system. So even still, though, we're working locally within our PDM system, and we hope that everything is up to date and accurate. There's no guarantee that our customers are looking at the most accurate data. And then if we have to update it after we sent it to them, even still, they don't have the latest data. So there's a lot of issues that we're still seeing today, even though we're using pretty good PDM systems, whether it be Windchill or some other tool, right? So everybody's questioning the accuracy of the data at that point, right? There, again, there's no guarantee that data is the most accurate. So, are files the root of all evil? Not necessarily, but they're certainly the cause of most scrap and rework and IP theft, because when you put those files out there, if it's not the most accurate and somebody manufactures to some drawing that's a month old, there's no guarantee that they're making it to the most accurate data. And certainly by putting that data out on an email or somebody else's server or system, there's no guarantee that they've got that stuff locked up. And so you see some IP theft with that. So, that's kind of enough about what I want to talk about, kind of how we got to where we are today. And what I want to do now is I want to kind of demonstrate how Onshape works in, to create CAD files and drawings and assemblies and actually collaborate with other users on the system. So with that, I've got Onshape already up and running here. And I thought I did. So I'm going to log into my Onshape system here. And when you log in, this is what you'll see. You'll see, basically your most recent activity. And then I'm going to go to my Onshape, and this takes me to my home page, if you will. And in this, I have, some folders or some documents that I've been working on, different products that I've been involved with, right? I can filter this by recently opened or created by me or shared with me, and anything with my teams and so on, any public data that I create, and then any trash. And so this is kind of my home page. If I create a new document, right? A document in Onshape is really kind of a holder of multiple types of CAD data here. And I'll just call this a temp document, just for lack of a better name. Well, let's just call this a base bracket. And I don't even need the underscore, to be honest. I kind of get used to doing that, and I'm sure a lot of you do too. So, when I open up a new document in Onshape, what I see here is what's called a part studio. And this is where we can create one or more parts that we might use in this product. And I can create additional part studios within this document. And you can think of the document as an umbrella that kind of covers this entire product, if you will. And then I have an assembly window here as well. And we'll get into that in just a moment. But within this part studio, I have, a typical CAD creation type menu where I can create extrudes or revolves, sketches, and so on. I have the ability to manage how, we rotate and see the view. I can switch to the top or to an isometric, and, very easy to use CAD interface, and, very similar to some of the other products that are out there, whether it be SolidWorks or AutoCAD or what have you. How we would go about creating CAD parts in an Onshape document is I would be working in this part studio, and I may create a sketch on a plane, right? And that sketch might include several types of sketch geometry. I might create a circle, right? And that circle might have a diameter of, say, 1. Maybe I have another circle, and that circle has a diameter of 0.875. Maybe I create a rectangle center and point, and then it has, 2 dimensions on that. And I'm just sketching this out and entering the dimension values as I sketch it, right? I can create construction geometry. So maybe I want to create a rectangle that is made of construction geometry that has a particular dimension scheme and so on. And I'm going to use that to locate some circles for my through holes here. So we'll just create a couple circles. And since they're through holes, we'll make them all be equal. So that is equal to that. That is equal to that. And that one's equal to that one. And then we can dimension these, separately after the fact if, the dimensions didn't show up or we didn't edit their value as they were being created. I'm just going to go ahead and create a dimension for the circle here, and we'll say it's 0.25 in diameter, right? So this is basically, kind of the shape or all the sketch geometry that I would need to create this bracketry, if you will. And, I can certainly move the dimensions anywhere I want to see them a little bit better, right? And just drag those around. All right, so this goes pretty quick. And like I said, it's, pretty similar to a lot of CAD products out there that require some form of a two-dimensional sketch to create some geometry, right? So I'll rotate that around. So now with this sketch geometry, I have multiple regions, if you will. So if I select on a region, I can extrude that region as a solid model, right? Or a solid, if you will. So if I select multiple regions, I can extrude them all at the same time. Now, with Onshape, there's no control key to select multiple objects. It's just a matter of selecting them. And then if I click out on space, I'm deselecting them. So if I wanted to extrude these shapes, I would just simply select them all, and then I would use my extrude. And then with that extrude, I can give it some depth. I can drag it, or I can specify explicitly that I want that to be, some value, right? Okay. And then when I create that first extrusion, it automatically hides my sketch for me. So I'm going to go ahead and turn that on just so I can see it. And then I'm going to extrude some additional shapes here. So I'm going to extrude this part of the sketched region. And so we'll extrude that, and we'll give it some depth. Now, when I create the next extrude, I have the choice to add to the first solid, or I can create a new solid if I choose. But in this case, I'm going to go ahead and just add it to the first solid. And I think the depth of 1 works pretty good for what I want to do. And then we'll say okay here. Then what I'm going to do is I'm going to just add some rounds to this. So we'll just go to round here, and I'll take that edge right there, and we'll say it's 0.125, and then okay that, and then I'll create some additional rounds. I'm just going to select all 4 of these edges. Again, there's no need to use the control key or anything like that. We just keep picking until we get all the objects that we want to manipulate. And in this case, we'll say that's 0.25, right? Now, if I want to go back and edit any of these after the fact, I can simply select on them, right click and edit. And I want that value maybe to be 0.0625. Okay. So very, very easy to create geometry. All right. Now what I'm going to do is I'm going to extrude some, another piece of this. So I'm just going to select on the solid here, that surface, and I'm going to extrude that as well. And I'll give it some, some length. I can drag it, or I can specify explicitly how big I want that to be. And in this case, it's defaulting to add. I'm going to say I want to create a new solid out of that, right? So now I have 2 parts. If you look down here in my parts, and these are not assembled, but they have some relation to each other in the fact that I'm using, similar geometry to extrude and create these parts, right? So if I change the size of one, the other will update, but don't confuse that with an assembly. We'll get to that in just a moment. So what I'm going to do though is I'm going to work on part number 2, and I don't want to necessarily see part number 1. So I'm just going to isolate that so that I can do some work on it. And then I'm going to shell it out to add some thickness to that. And we're just going to select both surfaces on that to create the shell, and then specify, how thick do I want that shell to be. Okay, so now I have 2 parts, and I'm going to turn off my isolate, and we'll go to this view. Now, one of the nice things about using Onshape that I like is, everything I need is kind of at my fingertips. If I'm not sure how to do something, I've got my learning center right here. I can click on that and it takes me to the Onshape Learning Center, and I can get little tutorials or, you know, self-paced courses or little tips and tricks if I need. Okay, so very, very handy. I also have keyboard shortcuts, right? So if I want to know, you know, what keyboard shortcuts are out there, I can take a look at that real quick. And you can even, you know, print this out if you need to, you know, have it at your desktop while you're kind of learning the software. So, you know, very handy that these tools are available to me. Okay, so if I want to at this point, you know, it names these parts for me. I can rename them, and I say, well, that's going to be my base, right? And then this might be my whoops, we'll rename that one, and we'll say that that's going to be my pipe. Okay. So now I have the parts in this part studio, and I might want to create the assembly at this point. So I'll go to my assembly, and I'm going to insert now, and I've got this list of parts that come from my part studio, right? So I'm going to pick on base, and it's going to snap to the default location. So I'm going to go ahead and just say, yeah, I want to just leave it right there. And then I'm going to insert this piece of pipe, and I'm just going to just put it out here in space, and then we're going to say okay here. And so that thing is free to move. I can just drag that anywhere I want, right? Now in Onshape, when we assemble parts together, we use these mate connectors, if you will, or mate fasteners, and we have varying degrees of freedom of motion that we can use to assign these. But if they're going to be you know, kind of just assembled rigid together, I'm just going to use this fasten mate. And these fasten mates will show up, these mate connectors will show up wherever I'm selecting on the geometry. And you can see as I move my cursor around that they're moving around as well. And I'm just going to select the one that I want to fasten, and then I'm going to move to this part, and I'm going to say, well, I want that to be right at the bottom of that there, and we'll say okay. So now those parts are assembled to each other. So when you look at the part studio, although you're building them sometimes in what might look like an assembly, they are not yet assembled together. We do this so that we can reference the geometry of the different parts to have that kind of associativity, if you will. So if we make changes to one, those changes could propagate to multiple parts if we need to. Okay, so you know, back to this assembly, you know, there we have it. Now I've actually created another data set that I want to move to now to kind of show you some of the, you know, the more advanced you know, part capabilities, if you will. So I'm going to go back to my Onshape homepage, and in this shortcut folder, I have this you know, bolt cutter that I created, and I have a demo version of that. So I'll go ahead and open that. Now with this demo version, what you'll see here is I have a couple of sketches, right? And I'm going to zoom in here so that we can see what we're looking at here. So I have kind of a layout sketch. This kind of locates, you know, some of the geometry, and then has, you know, where my pivot points or through holes are going to be. And then I have this, you know, blade and link geometry. If I were to edit that, it would take me to that. You can kind of see what that sketch geometry looks like. So you know, these things all have relations to each other as far as the sketch geometry, and then I'll use that to create my parts, right? So we just go back to my default here. So as you can see, I have a few different sketches in this. And then I also have this handle layout, which has a couple other sketches that are on different planes. So I just kind of organize that by creating this folder and adding you know, those sketches to that folder. Okay. Now when I start creating the solid features, I'm organizing them into different features that I would use. Now sometimes these features apply to more than one solid. So don't think of this just because I named it blade or link or lever features that they belong to those parts, but for the most part they do, right? That they don't have to. Right, the parts themselves are down here. As I create the new parts, and then give them a name. You can see the different parts. Now, what I don't want to do is I don't want to create parts that I'm going to use multiple times. I don't want to create multiple versions of them. For example, this blade and this link, I'm going to use them twice in the assembly, as well as the handle and the grip. The only parts that are unique in this assembly would be the right lever and the left lever, because they kind of link together, but everything else is the same, right? Or you're going to use two of each of everything else. So if I go to the assembly, right, again, I've assembled these parts already, just kind of get a head start, and I've put some fasteners in there, and we'll show you how that works in just a moment. But what I'm going to do here is I want to, add the, the additional handle, and we've got some kind of spring pins that come from our standard library. Then we'll put those in there as well. So we'll kind of show you how that workflow works here. So I'm going to insert from my part studio, and I can even go into other documents and pull parts from other part studios and other documents if I need to. So you can imagine you can create, pretty elaborate assemblies in doing this. But in this case, I'm just going to pull from my current document, and I'm going to just insert this handle here, one there. And then I also need another grip. So we'll just kind of throw that in there for now. And then we'll assemble these, right? And so as I mentioned before, we're just going to use these, fasten mates. And I'm going to just click on that. And I want to get, in this case, I'm going to get the end of this grip in here, just that one right there. And I'm going to put it on the end of my handle here. So just make sure I get the right one, just like that. And that gets fastened. If we had to, we can flip that to the other direction. But for the most part, it went together just the way I needed it. So I like what I'm seeing there. I could rotate it, although this doesn't, wouldn't do anything for me on this one, since it's, cylindrical. So I'll just go ahead and accept that, all right? And then what I'm going to do is I'm going to add another one, and I want to kind of get inside the handle here, and I'm going to grab, I think that one right there works for me in this case. And then we're going to put that right on the end of this other lever right there, and that gets assembled. Again, I could rotate it if I wanted to. Probably not a good idea, but just to kind of show you how that works. And I get it where I want it, and I say okay, and I'm done creating those fasten mates, right? And we just take a quick look at this. Okay, now if I go to insert again, and I have standard content, and in this case I have different fasteners, pins, clips, whatever. And in this case, since I've already used it the last time I did this, I was using the same spring pin. So I'm going to go ahead and insert 2 more of these, and I can just use the existing geometry here and let it just snap into place as I assemble this, as long as I can get it to highlight the one that I want there. There it is right there. And then we'll insert another one, and we're going to put it right on there. So as you can see, this stuff goes together pretty quickly, right? Okay, so this is also assembled as a mechanism, and I did that earlier. No need to spend too much time showing you how that's done. But if I drag one of these parts, you can see that it actually works as a mechanism. So that's pretty neat. And we can put stops on it, so it only goes so far in each direction. And that's just a matter of when I create that fastener, I use a certain degree of freedom, and then I give it a gear mechanism so it has a relation, and so that it all moves together. And we're going to have several of these webinars on Onshape, and we'll get into more detail of how to do some of these more advanced things in those webinars. But for today, we're just trying to keep it high level, very simple, show you how easy it is to get around in the interface. Okay, if I want to create a drawing, again, in these documents, we create part studios, assemblies, and even drawings, right? And I can create a drawing and assign a part to it, or I can, in the part studio, I can pick on one of these parts and I can actually create the drawing from here. So I say, I'm going to create a drawing of this link, right? And I can pick a format from my list. I could have more formats in here. I can create my own. I'm just going to use a kind of an ANSI B-size format in Imperial measurement here, and that's a standard template out of Onshape. I can choose to use a number of views or have no views, right? And I'll go ahead and say create one with no views at this point. And then this will open up the drawing and it'll want me to create a view automatically. So it's asking me, where do I want to put this view? And maybe I want to change the view orientation. Maybe I want to use a top instead. Maybe I want the scale to be 1:1 or 2:1 might be good for this drawing. So maybe we'll create that view just like that. And then it automatically is going to want me to create a projected view off of that. And so I can do that also. Once I've created my views, and I can come back and add more views later if I wanted to, but I think this pretty much covers everything for this kind of part. I can certainly move these views anywhere I want to move them and organize my drawing accordingly. Now, to create dimensions, this is pretty similar to some other tools where we're just going to create the dimensions for this drawing, and then we have a drop down here of different types of dimensions, but for the most part you can use just the default. If I pick one piece of geometry, whoops, I want to undo that. Do that again. I create one piece of geometry, pick another piece of geometry, and place that dimension. Maybe I want to put a dimension between the holes. Maybe I want a dimension for the hole. Okay. Maybe I want to go a maximum outside dimension. So we'll do that, and we'll pick, those two entities, and we'll put that dimension there. Now we just want a standard dimension here for the thickness. We'll do that. And so as you can see, it goes pretty easily here. And then I want to put a radius dimension on the end there. Oops. Like that. And then when I create a dimension, I can certainly tell it, I want this to be 2 places. Okay. Just like that. Pretty simple. Same thing with the hole, right? I want to modify that. I can pick that dimension and say, well, there's 2 of those as well, 2 times, right? Maybe I want to add some geometric tolerance to that. I can do that as well. Put it on that dimension, true position, 0.00, whatever the case may be, right? And then datum A and B. Right. So pretty simple to create this geometry. Whoops, didn't give me my tolerance there. 0.003 with datum A and B. There we go. All right. And so very easy to use, creating drawings. One of the nice things that we can do here is, we can work collaboratively with, other users in the system. Now, one of the nice things about Onshape is I don't have any hardware to support. It's just basically a login. So if somebody else logs into the system and then opens up this document, I'll see it immediately that there's somebody else in the document. So for example, I've got another computer here in my office, and I'm going to open up this document, and you can see right away that there's this user shows up here. JP has got this document open, right? And I'm going to look at the parts here because that's what JP is working on. You can see this icon down here. J is actually active in the parts. And what I can do is I can message JP through the comments. I can say, hey, hi JP, right? I see you are working on the bolt cutter, right? and we can add that comment. And that immediately shows up in JP's window, right? And JP can respond, and I'll just say, yes, making changes, right? And when JP replies, I see that instantly here that JP has said, yes, making changes. Well, I can say, well, what change? And reply, and then JP can respond accordingly. Right. Oh, JP is going to change the thickness of the link. Well, what I can actually do here, which is kind of neat, is I can double click on this icon here and I can watch JP make the change. All right, so if I double click on that, you can see that I'm following up here in the upper right, I'm following JP. And even though, you know, my cursor is still visible, anytime JP moves, I can see JP's cursor. So if JP zooms in or zooms out, right, I can see what JP is doing. So if JP goes to work on, say, the link features and changes the extrude and edits it, I can kind of see in real time what JP is doing. And so this is kind of a really neat feature within Onshape. And so JP is changing the thickness, and I see that instantly on my machine, right? And if I want to, I can even go up here and look at versions in history, and I can see who's kind of doing what. So if I say show changes today, extrude 3 was changed by JP at 11:42 today. Well, maybe I want to, you know, kind of be able to go backwards and save a version of this before those changes were made. So I can very easily select on that level of the document, and I say, well, create a version here, and the description might be before JP changes, okay? And I'll just create that version. So now I can very easily go back and see what was done before JP made the change, right? And if JP makes more changes, I would see them here in this list. So, you know, very, very handy that I can go back and see who's doing what and when, right? So I'm going to go ahead and you know, make sure that I'm current with this before I do anything, and I can see that that thickness has been changed. Now, my drawing, I had already created the drawing. So if I go to my drawing, you'll see that it's going to be updated by the simple click of update from the workspace. And I just click on this icon. This shows up saying that, hey, there's been some changes here. So if I say update, I see the current changes to this drawing. Okay, and so that's how easy it is to use this tool. So with that, I got a few more slides to show you, and then we'll open up for some questions. So you know, if we look at the existing tools that we have today, you know, they're all built on older generation technology, right? Or even previous generation technology to Onshape. You know, there's a huge IT overhead on the tools that a lot of us are using today, right? There's, you know, a very rigid process, is not very flexible, you know, using some of these tools. And it's a culture based on serial or sequential operations. I do one thing, I do the next thing, and then if somebody else wants to work on it, I got to let it go and you know, they do their thing. As you saw in the previous demonstration, there were two users working on the same data at the same time, and we were able to collaborate and communicate and see what each other is doing, right? And certainly there's risks associated with protecting the, you know, massive amounts of data and IP. So if we look at, you know, if we could, you know, reimagine what this product development process looks like, it of course involves the cloud. If you'll notice, there wasn't a file icon or click in Onshape. It's automatic. Anything I do is saved automatically to the cloud. And this is what the cloud might look like, you know, Amazon data center, if you will, right? So, you know, of course, with you know, our current infrastructure, you know, a lot of us are using more platform or software-based infrastructures, but currently, you know, everything that we use, the application, the data, the operating system, is all user managed, whether it's by me as an end user or by my IT department. You know, somebody's got to manage this stuff, right? Well, if we look at a provider managed, you know, environment, where our infrastructure as a service, you know, we're still managing the application and the operating system and so on, but we may outsource the visualization or the storage or the servers. Now, if we look at, say, maybe a platform as a service, you know, we're still managing the application and the data, but everything else is being outsourced. But if we look at a true software as a service type application, all that requires is a login. And it doesn't matter whether you log in from a laptop or a desktop or a tablet for that matter, you're still seeing the same interface, the same data, right? So very, very easy. And you know, if I want to add a user, I don't have to buy a new machine. I don't have to link it to a network or create a server login. It's all part of my, you know, core system, right? I just create the user and I'm good to go, right? Now, the benefits are that certainly it's instant deployment. There's no downloads, installs, upgrades, service packs. I mean, everything's upgraded automatically. Every time I log in, if there's been some upgrades, I'm getting the latest and greatest, right? So, you know, instant user provisioning and deprovisioning. Zero IT overhead. Now, I wouldn't say necessarily zero because, you know, somebody does have to create my users, right, and manage, you know, who has, you know, access to what data and so on. But I don't really rely on an IT department. I mean, that could be done by, you know, one person as a super user or an engineering manager who has those permissions and so on. And all my database is, you know, centralized. You know, everything is stored in one database in the cloud, right? Everything's current. I can certainly go backwards in time and look at different versions and save those out and so on. But everything I do is stored in the cloud. So I don't risk sharing that IP with, you know, sending it out on a you know, email or a thumbnail drive or what have you. So they're very you know, safe data storage. Okay. So at this point, I'd like to open up for questions, and I have looking at questions here. I see one. Creo parametric. Can Onshape files be exported from Onshape and imported into Creo parametric? Sure, I can export Onshape files and then import them into Creo parametric, or vice versa. However, you have to keep in mind that that's a neutral transfer. You know, I cannot bring in that history or feature history, if you will. I basically get a neutral file format, very similar to an IGES or a step file. Okay. Other questions? That question was from Marvis. Hey, Marvin, how are you? Hope you're doing well. Okay, well, Alex, I don't see any other questions popping up.
Yep, looks like that is it. So thank you guys for joining us today. If you have any questions, you know, feel free to visit our website or reach out. Be happy to kind of go into more detail. Everyone will get a recording of this sent shortly after. And with that, enjoy the rest of your day and have a great Thursday and Friday and a great weekend.
Thank you, everybody.